And I started the morning by dropping the camera on the floor while it broke into 4 different pieces. But I found all the pieces and I put them back together. And are we filming? And I look good? I always look good. Okay, so last night I filmed your homework for tonight. And you guys should have all gotten an email. Okay, so the way it's going to work is you are watching, it's called Special Topics, Continuity, and Differentiability. Go, like, think back to like August, September stuff. This goes along with, I think it's pages 9 and 10 in your Special Topics handout. And your job for 17 minutes and 22 seconds is to take notes, to listen, to be part of the conversation. Tomorrow when you walk in, you're going to have an activity that you're going to do, and I'm just going to walk around and be like, show me your notes, show me your notes, show me your notes, show me your notes. You got the notes? Check. Great. Good. Nothing for me to pick up. Okay? The nice thing by doing this is I've never done this flipped classroom idea before. My thoughts on the benefits, number one, is that it is going to give you a very manageable amount of calculus homework that you need to do, and then maximize the work that we can do in class so that you're not going home and you're like, oh, I've got an hour's worth of calc, and some of you only spend 10 minutes on this hour's worth of calculus. Okay? I promise you the videos will be in total no more than 30 minutes so that you can fit this in, because I know all of your other AP courses are probably hitting it pretty hard right now. Okay? I get that. All right, so 0 tolerance for anybody who comes in and I don't have it. What's going to happen in class every single day, you're going to come in and you're going to take out that pathway to excellence. You're going to have it handy all the time. That's the orange document. For those of you that maybe were absent on Friday, I've got one for you. That needs to be out. Your name is already on it. And I'm going to check whatever the homework is. If you've got the homework, check. If you don't have the homework, X. There's no partial homework. There's no, I forgot it in my locker homework. There's no, I'll give it to you later. You have it or you don't have it. It's 100% complete or it's not complete. Okay. At the end of every class, I'll then do another lap, and I'm going to need some help reminding with a reminder about this, where I'll go through and I'll look at engagement in class, and it's either going to be like, hey, this was really good, or it was like, it was okay, or it wasn't good at all. If it wasn't good at all, you're losing points from your possible test grade. If it's better than I would have expected, you're gaining extra points towards this test grade. The test grade should be an A across the board for all the friends. Last thing is, while you're doing this activity I'm going to have you do this morning, I need to make sure that I give signatures for anybody that attended AP Summit number 1, the one at East End, or AP Summit number 2, the one at Brays Oak. So make sure I sign your card there. All right. And I've got a whole bunch of students I need to check in with, but that's about it. Questions that folks have for me? Okay, please have your test corrections out, the ones that you did this weekend. I need to see that you did those, Kevin. Yes. If you were absent, it's going to be your responsibility to get with me and make sure that you actually have done them. We'll do that later. All right, here's what you guys are going to do. I need you to find in your survival guide, please. This is in Unit 1. It's pages 4 through 6 and 8 through 9. This is an independent, insert the word silent reading time for everybody. Back in the world of limits, there was all sorts of stuff that we learned. Things like the squeeze theorem. Things like relative growth rates. Which functions grow fastest? Which ones grow slowest? What does it mean when you're taking the limit of that ratio? How you evaluate limits from a graph. That tends to be an easy thing. You've got 8 minutes. Everybody should have a pen and or a highlighter in hand so that as you're reading, you're highlighting important information, and then we're going to spring into action after this. Questions about expectations? Excellent. Okay, coming around. Let me take attendance and do all the things.
What page?
Everybody's reading.
4 through 8. For these? This is the unit packet. Unit 1 packet, you know.
Yes, sir.
You're welcome, ma'am.
Thank you.
have to find it again.
When you find dirt on the top and bottom, oh no.
Okay, I guess, yeah. Okay. All right, so I'm coming around to all the tables. I'm looking at corrections from the progress monitor that you guys did this weekend. I'm giving out signatures for AP Summit 1 or 2. Make sure you know which one it is. And please just have the card ready with your name on it so I can go quick like a button. Okay, all right.
That's not confidence for
Maryland's here.
really had
The green folder?
Ah. Well, we're making the most of this time, right?
yeah.
Axel. Jeanette's not here. Mario. Paul.
You don't know the low room? What that is? Well, so when you plug in 0, you get an yeah, so then the hospital the bottom. But the derivative of the bottom will be 1, and the top will be low minus 0.
All right, let's take over here. Show me all the fractions. Okay.
Wait, so what's the difference between the intermediate value theorem and the... Oh, we're supposed to put it in? It's 6 and 2, right?
Okay, you need to tell me about that.
Yeah.
And you went to the first summit. To the first one. And Val, did you go to one of the summits? Okay, so you need to tell me that. As big as my brain is, that doesn't fit. Alright, first one.
Intermediate value theorem and
You just got it, okay.
He didn't really put it in. I tried looking for it, but I couldn't find it.
You went to the first summit?
Okay, so the intermediate value theorem, it's just like it's like continuous, and that's it continues and different. Let's see.
Oh, yeah.
Find
the derivative and everything. Like, why would you plug in 0?
Okay. Little more corrections.
Wow.
And go to the summit, make sure it's
Oh, there you go.
I don't show my So it's one zero is something has low first half, but the derivative 1 is 0. X plus 3 times 0 minus half.
Hey, I don't do that.
Derivative of x plus 3 is 1. Yes. All of it flow low. Derivative action I have corrected my Mario, and then check the same box. Make sure that anyway you crossed it off. One more light.
Yeah. All right, friends over here. You can just flip through. Okay, so that's homework. You get your survival guide. We went to the second summit, right? Okay.
I made a fool of myself.
In a bit.
I got one
Nice. Okay, so that's the homework. You get your survival guide, and we went to the first summit. Okay. Karina went to the second summit.
I made a fool of myself. I don't know what I was saying. I feel like one of the teachers thought I was cool.
And I already came over here and took care of you guys, right? Okay, good.
Maybe it was me.
All right, friends, time's up. Not too bad. Now, I've still got a bunch of folks that I need to check in with for different things. For example, if you didn't turn in your multiple choice corrections to the common assessment, or the free response corrections to the common assessment, please put those in the middle of the table right now. At this point, I'm not picking them up. It is going to be 2 really large missing grades if I do not get them right now. And for folks that were absent on Friday, there was some information that I gathered on everybody that I need to get from you, but I'll handle that later. Okay, so here's what I want to do. Now that you've had a chance to go back to the world of limits. Okay, limits is our bread and butter. It is like the first calculus thing that you learn. It is day 1 kind of stuff. At this point, I would expect that limits are good for everybody. Jackie?
Did you go over the intermediate value theorem?
We actually have a whole day set aside for all the named theorems. The IVT, the EVT, the MVT, all the theorems with names. Okay. We got a whole day for that, okay? What I want to do is I want to spend the next 20 minutes looking at some different kinds of limit questions that you're going to see on the AP exam, and these are the ones I would expect are going to be like high scoring for all the friends.
Is this on page
It's on page 1. Okay.
Special topics.
Yeah. Now, moving forward, this is not the kind of thing I'm going to be doing in class. This is what's going to get captured on the video. Since I didn't get a chance to film this last Thursday night, I couldn't give it to you in advance. Okay? So this is going to be probably the last day where it's like heavy on my talking. But moving forward, this is what's going to get filmed. All right, so let's look at a couple of these, maybe not even all of these. All right, I want to find the limit as x approaches 2 of x squared minus 2x over x squared minus x minus 2. And my thought is that most of you all are going to do the thing that we do all the time when it comes to evaluating limits, which is plug in. We like to call this direct substitution. Now, if you do plug in, you're going to get 2 squared minus 2 times 2 over 2 squared minus 2, which is 0 over 0, which is an indeterminate form, right? We know this vocabulary term. Now, some of you know that you have an option available to you right now. As soon as you see this indeterminate form, you might get really excited and you're going to think to yourself, what are we going to think to ourselves? L'Hopital. I love the fact that you're thinking L'Hopital. L'Hopital is fabulous.
And you can use it. You can.
You can't use it?
I want to do this problem twice. One where we use it, one where we don't.
Oh.
Okay? Yeah.
Could you separate the, not separate, but factor out the,
Yeah, so let's look at the old school way, right? What we would have done in August before we knew derivatives, we would look to factor. You'd say limit as x approaches 2 in the numerator, you can factor out an x. In the denominator, you can factor as x minus 2 times x plus 1. I'm deliberately going fast because I want to get you guys to the practice time. And the x minus 2's are going to cancel each other out. You then take the limit as x approaches 2 of x over x plus 1. We try plugging in again and we get 2/3. This would be the kind of question I would expect everyone is able to get a question like this right. This is a gift from the College Board. 90% or more are going to get this right.
Sure.
Are all the friends okay?
Maybe.
Okay. Now, L'Hopital, and here's where I've got to be super picky. L'Hopital, is it okay to use L'Hopital's rule right now? Once you know you've got 0 over 0, yes, absolutely, absolutely. But here's what the College Board says. If you do this work and say 0 over 0 on free response, they're not going to give you the credit. To use L'Hopital, you have to show me the limit as x approaches 2 of the numerator separate from the limit as x approaches 2 from the denominator. You need to handle them not as a fraction, but as 2 different limits. They don't like 0 divided by 0. It's a problem. Well, what happens when I take the limit as x approaches 2? 2 squared minus 2 times 2 is 0 in the bottom. 2 squared minus 2 is 0. Is it okay to use L'Hopital?
Yes.
It's still an indeterminate form. And so then I'd say, oh, by L'Hopital, take the limit as x approaches 2. And you got to be careful. Limit as x approaches 2 of the derivative of the top, which is 2x minus 2, of the derivative of the bottom, 2x minus 1. Now do your direct substitution and simplify, and you get 2/3. Which way is better? They both work, right? There's nothing wrong with either one of these methods. Old school, you factor and you cancel. New school, you use L'Hopital, but this has got to be super important. You have to evaluate the limits separately. You can't do this 0 over 0 business. They're not accepting it anymore. They used to, they no longer do. All the friends okay?
They make my life harder.
They're making your life a little bit harder, and so am I. Sheila.
how do you know when to use
Great question. Somebody answer that question for her. How do you know that L'Hopital is the way to go? Andy?
0 over 0?
When you get 0 over 0 or infinity over infinity. Either of those two things are an indeterminate form. Anything else is your answer. Karina?
How will you get infinity over infinity? Unless it's just a
What a good question. Let's come back to that in just a little bit. All right. Let's look at example number 3. Like I said, we're not going to do all these. Example number 3. Have a quick strategy conversation with somebody near you. What would you do? If we're talking about the free response, you're going to have to do a separate work over here. You have to do it separately. else have homework for me that I need to pick up, look at? Thank you much. Sure. I am moving seats around tomorrow.
I got 1/4. Can we find the derivative of something like that?
All right, let's get some hands on this. Options. You see this limit question. What are your options?
L'Hopital.
Direct substitution.
Direct substitution, L'Hopital. These are your two. Where are the folks that tried direct substitution? Paul tried direct substitution. Daisy tried. Crazy Daisy. Okay, if you do direct substitution, you're going to get square root of 0 plus 4 minus 2 over 0, which is 2 minus 2 over 0, which is 0 over 0. Back in the day, before L'Hopital, there was something you would do to handle a limit like this, and I wonder if anybody remembers. Square root of x plus 4 minus 2 over x. You're getting 0 over 0. What was that, Andy? No, Paul, how about there's a fancy word for it.
Fancy one.
Okay, fancy. Yes, there's that. But there's actually like a mathematical word for it. It starts with a C and does. Conjugate. You multiply by the conjugate. I want you to know the technique as well as the shortcut. If you multiply by the conjugate, what that means is you're saying limit as x approaches 0, square root of x plus 4 minus 2 over x. The conjugate involves looking at the part of the fraction that has the radical and multiplying by the same expression with a different sign in the middle. So in this case, you'd multiply by the square root of x plus 4 plus 2 over the square root of x plus 4 plus 2. Is that legal?
Yes.
Yeah, because this is fancy 1. But it's a carefully chosen fancy 1. What you would do is you'd say, let me take the limit as x approaches 0. When you multiply out the numerator, square root of x plus 4 times square root of x plus 4 is x plus 4. Square root of x plus 4 plus times 2 is 2 square roots of x plus 4. Negative 2 times all that, minus 4.
Oh.
In the bottom, now you get x times the square root of x plus 4 plus 2. That's ugly.
Yeah.
It's ugly. But good stuff's about to happen. Who sees it? What's the good stuff here? Gonzalo, what do you say?
You get the top can just be x plus 4 x, right?
Okay, we've got x plus 4 plus 2 square roots of x plus 4 minus 2 square roots of x plus 4.
I canceled out the plus 2 square root of x minus 2 square root of 4.
Everybody okay with canceling those out?
Mm-hmm.
If you can do that, there's also something else.
And then I cancel out the 4 and the negative 4.
The plus 4 and the minus 4. So now you've got the limit as x approaches 0 of x over x times the square root of x plus 4 plus 2. And that's good. Destiny, what are your thoughts here? What else could we do?
Cancel out the x.
Right, because it's a factor. It's a common factor in the top and the bottom. Now you've just got to evaluate that limit as x approaches 0, 1 over the square root of x plus 4 plus 2. Now I would try direct substitution. You're going to get 1 over the square root of 4 plus 2, which should be a fourth. Yeah.
What was the way you taught us where like we plugged it in and you said as like e approaches something, e of x approaches something?
That's coming. That's coming. Good question. All the friends okay?
Mm-hmm.
Okay. That's the old school way. Can we use L'Hopital?
Yes.
Now here's the thing, you have to convince me. If this is free response part of the test, you have to convince me. And you guys saw this on the common assessment a week and a half ago, and nobody got the points for this. If you're going to use L'Hopital, you have to evaluate the limit of the top and the bottom separately. Limit as x approaches 0, square root of x plus 4 minus 2. Then find limit as x approaches 0 of x. What happens in the top? Square root of 4 minus 2 is 0. In the bottom you get 0. Can we use L'Hopital?
Mm-hmm.
Of course you can use L'Hopital. So by limit as x approaches 0, derivative of the top, then derivative of the bottom. Derivative of the square root of stuff
1,
is 1 over 2 times square root of the stuff times derivative of the stuff, which is 1, minus the derivative of 2, 0. In the denominator, derivative of x, 1. That's what L'Hopital tells you to do. Now take the limit as x approaches 0. 1 over 2 square roots of 4 minus 0 over 1. Hey, it's 1/4. It's the same 1/4 that you get by multiplying by the conjugate. L'Hopital is your friend. But only if you do this right. Top, bottom, do them separately. All the friends are good? Okay, good. All right, let's keep going. 2 more. And then you guys are going to get practice time. I'm going to get water. All right. Oh, good luck. Good luck with number 3. Have a strategy conversation with folks around you. What's going on here?
4?
Number, example 4.
8.
Isn't that one row of something?
No.
This is formula.
X plus 8. Isn't it X of 8? No, it's X plus 8.
Over X.
I don't forget how to do it. No, X of X plus 8. Okay, so F of X is natural log 4. So basically that's everything in the format. Yeah, it is in the format. Oh, okay. Then you try to...
I am such a proud papa. There are so many people right now who are like having flashbacks, and they're like, this is one of those sneaky questions. Yes, it is. It's got the form f of a plus h minus f of a all over h, and we're taking the limit as h approaches 0. This is a special form that I would want you to have memorized, because what is this form actually asking you to do?
Slope. What's the derivative?
This is the derivative
It is?
Yeah.
of your function
Oh.
at 4. That's what this form means. F of a plus h minus f of a all over h. Take the limit as h approaches 0. This is your derivative. Well, what's the function? What's the f of x?
Natural log. Natural log.
Right,
4.
f of a plus h, it's natural log of x at x equals 4. Oh my goodness, I think we all know what to do here. What's the derivative of natural log?
1 over it.
Okay, derivative of natural log of x is 1 over x. So what's the value of the derivative at 4? 1 over 4.
1.
Easy if you see it. Impossible if you don't. So those of you that were gifted and you remember that special form, yay for you. Yay for you, it's a quick question. Did anybody not see this? Thank you for the honesty. Like, I think the calculus students who just see this all the time, they're rare. So what other option do you have?
L'Hopital.
Could we use L'Hopital? Take a minute, convince me whether or not you can use L'Hopital here.
Yes.
Don't just say yes and oh yes! Convince the college board that you can use this. Some people. Can I use L'Hopital? Oh yeah, we did it in the last 2. The college board is looking for something very specific here. And I'm seeing some people doing it. You take the limit as h approaches 0 of your numerator. You take the limit as h approaches 0 of your denominator. In the top, I get natural log of 4 minus natural log of 4, which is 0. In the bottom, I get 0. Can I use L'Hopital?
Yeah.
Of course you can use L'Hopital. Well, what does L'Hopital tell me to do? Take that limit as h approaches 0, derivative of the top, natural log of stuff is 1 over 4 plus h minus derivative of natural log of 4.
1 over 4.
0.
I'm hearing 1 over 4 and I'm hearing 0.
0.
0.
0.
I choose my answer to 0 because it's a constant, right?
Wait,
There you go. Natural log of 4 is a constant. And because the natural log of 4 is a constant, what's the derivative going to have to be?
0.
0. Take the derivative of the bottom, 1. Now you plug in 1 over 4 plus 0 minus 0 over 1 is 1/4. L'Hopital is wonderful. It is a powerful friend to have. It is your ally in your fight against the College Board. I think I'm having a Star Wars moment right now. It's about to go all Yoda.
Mr. Kingdom.
Okay, Eva.
But you don't need to explain why, like, if you just take the derivative of ls and then say that the final point is 1 over 4.
I would expect a question like this on the multiple choice, and on multiple choice, the nice thing is you don't explain anything. You just circle the right letter.
So then, like, if for the free response, we would have to like L'Hopital and explain.
When it comes to free response and L'Hopital, you have to do it this way. You have to separate your denominator and your numerator, show that they both go to 0 or infinity, and then go from there. Karina.
Does the College Board usually ask about L'Hopital and free response?
Absolutely. Sheila.
When you find out the derivative, you don't need to separate them, you can put them together.
Right. It's not. I think the thing that happens with a lot of folks, they think L'Hopital and quotient rule. Right? You get confused. L'Hopital is not quotient rule. You are finding a derivative, but it's derivative of the top, derivative of the bottom. Not quotient rule. Daisy.
Well, we have a question of free response where it says like to not use L'Hopital to like.
I'd be surprised if they said, and you can't use L'Hopital. But what's happening is L'Hopital's rule is getting built in on the free response, and that first point is, have you justified the fact that you can use it? And then the second point is, do you come up with the answer? And a lot of you on the common assessment a week and a half ago got the answer point, but didn't get this point. All right, last one, and then it's work time. Okay, limit as x approaches infinity, e to the 2x plus x over x to the 4th minus 3x squared. This gets to the question that many of you asked earlier. Are there other indeterminate forms?
Yes.
Yes.
As
As
x approaches infinity.
x approaches infinity, what happens in the numerator? Think about your graph of e to a power. Increases, right?
Yeah.
So as x approaches infinity, what happens here?
Infinity.
Infinity plus infinity, guess what?
Infinity.
Infinity. In the bottom? It's a degree 4 polynomial.
Infinity?
You guys know something about the ends. Degree 4 polynomials. Degree is even, so they go together. Do they go up or go down?
Yeah.
They're going up. What's the limit as x approaches infinity?
Infinity.
Infinity. Okay. This is not equal to 1. This is another indeterminate form. Now, some of you could make quick work of this right now. There's something that you know. There's something that you see. You're dealing with limits as x approach infinity. You have e to the 2x compared to a polynomial. If you don't know, take a minute, go back to your notes. Go back to that survival guide. It's in Unit 1. This is about relative growth rates. I won't say anything.
Yeah, because I would think of what I was thinking was like when we were talking about like how like it was like to going to like the degrees and like you can know
Okay, what you're looking for, it's called relative growth rates.
So this one's bigger?
And where is it?
Relative magnitude?
Relative magnitude.
Yeah.
What page?
8. Page 8.
Page 8. But really what you need is at the bottom of page 9. I would highlight the bottom of page 9. Bottom of page 9, this tells you which functions grow fastest. Which one is the fastest growing function ever?
Exponential
The exponential.
Exponential functions grow faster than polynomials, even polynomials very large degrees.
Right. Because you have an exponential in the numerator wins. Because the guy in the denominator is just a polynomial. So in terms of like growth rates, it's the exponentials first, then it's your polynomials, and then the slowest growing one are the logarithmic functions. I always think of those as like the slog function. They grow really, really, really slowly. With the exponentials, the bigger the base, you know I'm all about the base. The bigger the base, the faster the growth. With polynomials, the bigger the exponent. Oh, apparently I'm still all about the base. The bigger the exponent, the faster the growth. All right, so which one grows faster?
The exponential.
The exponential grows faster. So what's the limit? What's that limit? The exponential grows faster.
Infinity.
You're going to head off to infinity. Done.
How will we explain this in Fourier forms if we ever could?
Probably wouldn't be asked to.
Multiple choice.
Multiple choice? There it is. This is done. Exponential grows fastest of all, then the polynomials, then the log function.
Oh, would square root count as a polynomial?
I would include the square root as a type of polynomial where it's degree a half. Destiny.
And does the sign matter? Sign?
The SIGN?
SIG.
The top goes to positive infinity, the bottom goes to positive infinity, so the whole thing's going to go to positive infinity.
But if it was negative e to the...
If it was a negative e, then this would be a negative infinity. Nice job. All the friends okay? So that's like it for me when it comes to limits, L'Hopital, and relative growth rates. In the future, this is going to be the thing that you're watching for homework, and you're taking notes, and we're having, I'll pretend to have a conversation with some of you, and then you're going to come in and it's just going to be work time. Okay, we've got about 12 minutes left between now and the end of class. There are 14 multiple choice questions starting on page 4 of the special topics. As brilliant as you all are, no one's going to finish all 14 in the next 10 minutes. That's fine. This is where you just go as fast as you can and you answer as many as you can. For those of you that are hungry for like, I want to show you how much I care about this, between today and tomorrow, finish them all off. I will gladly give you like an extra check in the participation column, which means your test grade goes up a little bit more than somebody that just does the work right now. For me, tonight you only have 17 minutes worth of homework, which is one video. You could easily knock out the remaining questions. All right, nice job. And we're going to stop filming at this point. And let's see, friends.